Hey everyone, and welcome. Today we're diving into something that's all around us, every single second of the day: force. I mean, it's literally what holds the universe together, from planets spinning around the sun to you just picking up a cup of coffee. But what is it really? Let's find out. Okay, picture this. You're pushing against a solid brick wall. I mean, you're giving it everything you've got, right? You're sweating, your muscles are shaking, but that wall, it doesn't move, not even a millimeter. So you're definitely using a ton of force, but where is it all going? Why isn't anything happening? That little puzzle right there, it's the key to understanding, well, everything about force. So, to crack that puzzle about the wall, we've got to start at the beginning. We need a simple definition. Now, the word force can sound super scientific and complicated, but I promise you, at its heart, it's something you already completely get. And there it is. Seriously, that's it. A force is just a push or a pull. Every single thing that happens, every interaction, whether it's a magnet grabbing a nail or you tugging on a rope, it all boils down to one of those two simple actions: a push or a pull. Just think about what you did this morning. You pushed the snooze button, you pulled open the fridge door, you pulled your heavy backpack on. Every single one of those moments was you using force. See? You're already an expert at this. But here is where things get really cool. A force doesn't just, move something from here to there. It actually has what I like to call 4 different superpowers that can totally change what an object is doing. First off, force is like the ultimate on-off switch. It can get something moving or stop it dead in its tracks. It can also be a gas pedal or a brake, making things speed up or slow down. Then it can act like a steering wheel, changing an object's direction. And finally, if you use enough of it, a force can actually change an object's shape, squishing it, stretching it, or bending it. And you can see these powers all over the place. A goalie's hands apply a force that stops the ball. A friend giving you a push on a swing changes your speed. A baseball bat hitting a ball completely changes its direction. And of course, crushing a soda can, that's force changing its shape. 4 totally different results, all from the same basic idea. All right, so we know what force is and what it can do, but how does it actually, work? Well, forces basically come in 2 main flavors. You've got the ones that have to touch, and then you've got the ones that seem to work like magic from a distance. The difference is pretty straightforward. Contact forces, just like the name says, need to be physically touching something to have an effect. But non-contact forces, well, they can do their thing from way across the room, like an invisible hand pushing or pulling. Muscular force is the most obvious contact force, right? It's literally your muscles pushing or pulling something. But another huge one is friction. That's the force that pops up whenever 2 surfaces rub against each other. It's what makes a soccer ball eventually slow down and stop on the grass. And then we have the magic ones, the non-contact forces. Gravity is the big one here. The Earth pulls an apple from a tree without any strings or anything. And magnetism is just as wild. A magnet can drag a nail across a table without ever touching it. These forces are literally acting through empty space. Okay, we now have all the clues we need to finally solve the mystery of that unmoving wall. And the secret? It all comes down to thinking about forces like a giant game of tug-of-war. This right here is the golden rule of the game. When you have forces pulling in opposite directions and they are perfectly equal, they just cancel each other out. The total force, or the net force, is 0. And the result? A total stalemate. Nothing moves. Just look at this tug-of-war. If Team A and Team B are pulling with the exact same amount of strength, that little flag in the middle is not going anywhere. This is what we call balanced forces. The pulls are real, they are strong, but because they're in a perfect standoff, there's just no change in motion. So this is where it all happens. A standoff can't last forever. What happens the second one team starts pulling just a little bit harder than the other? The moment Team B pulls harder than Team A, that balance is gone. Instantly, the rope starts moving in the direction of that stronger force. This is an unbalanced force. And this is the absolute key to everything. Things only start moving or speeding up or changing direction when the forces are unbalanced. And there's our answer. When you were pushing on that wall, you weren't the only one pushing. The wall was pushing back at you with an equal and opposite force, using its own structure and the friction with the ground. Your push and the wall's push back were perfectly balanced. You were in a tug-of-war with a wall, and it was a tie. Which brings us to friction. the secret hero or villain of our wall puzzle. Friction is one of the most important forces in our day-to-day lives, but it kind of has two sides to it. Sometimes it's our best friend, and other times it's our worst enemy. Seriously, think about it. Friction is a total hero. It gives our shoes grip so we can walk without slipping, and it's what allows our car brakes to actually work. But it's also the foe that wears down the soles of our shoes and makes engine parts overheat and break. It's this constant battle.
Want to feel it right now? Go on, try this with me. Rub your hands together really fast. Go, go, go. Feel that? That warmth building up? That heat is friction right there in your hands. You're literally converting motion into heat energy, all thanks to that one force.
So let's do a quick fire recap of everything. We learned that force is just a simple push or a pull. We found out it has 4 superpowers: to start, stop, steer, or shape things. We saw that some forces need to touch and others work from a distance. And the number one rule we learned: nothing moves, nothing changes, unless the forces are unbalanced. So I'm going to leave you with one last thing to chew on. We know friction is totally essential. We need it to walk, to drive, to do almost everything. But we also know it causes things to wear out and waste energy. So, in the grand scheme of things, is friction more of a friend or a foe? The answer is not as simple as you'd think. Thanks for digging into the secrets of force.